Hello, welcome to meetup number 67 of Beginners, Python and Machine Learning. We do a weekly series, and the first week of every month we try to go right back to basics, and so that's what this one will be, and teaching people how to get started in Python right from the very beginning. And then during the month we have a couple of weeks of machine learning. So next week and the week after will be machine learning. We'll be concentrating on, and then the following 2 weeks we'll do some just Python programming issues. So like last month we did how to send emails from Python and how to create PDFs. But today is for absolute beginners, and so we're assuming no knowledge of Python. So we welcome questions. If you've got any questions, feel free to ask questions on the YouTube chat, or if you've enrolled in Slack, we're in the Learning to Code channel on Beginners Python Slack channel. Hopefully you've registered for the meetup, and so you'll see the a URL. We've got a starting point. We're going to use Google Colab, which is a cloud service offered by Google for free that will allow us to do Python programming, and you don't need to install anything on your computer. You will need a Google account to do this. So there's a link in the meetup. There's also should be a link below the YouTube video. So if you click on that link, you can just go straight to colab.research.google.com and create a notebook from there, but this link will take you to a pre-filled out notebook, and so you can just run the exercises without having to do all the typing. It'll let you do extra typing if you want. So let's get started. So clicking on that link will open up it's a Jupyter notebook in Google Colab. And Jupyter notebooks are a way of writing short Python scripts, and it's an interactive Python. It's like an extension to Python called IPython, and Jupyter notebooks takes IPython just a couple of steps further. So for learning, this is a really good way because you're interacting with Python. You can type stuff in, you get an immediate response, and so you can see what's happened. I've set challenge 1 is install software. So you can install Python 3 by going to python.org downloads, but we don't need it for today's session. Alternatively, you can install Anaconda. That includes many third-party libraries. So some people like everything that comes with Anaconda, so they'll just go straight to using Anaconda. If you're doing Python programming, I'd recommend an IDE. It makes it a lot easier to write programs, and it does a lot of error checking. It gives you hints on what you're doing wrong, and it gives you tools to see what's going on. But today we're going to be using Google Colab, so let's go. You'll see the name of the notebook up here, Meetup 67. Tim, that's me, and we're just doing, it's for the beginner, so we're looking at variables and data types. We'll also be looking at a few other things, how to write short scripts in Python, and a few structures like conditionals and loops. But if we tried to go and save this, it'll say we cannot save changes because you're looking at a copy of my notebook. So what you probably want to do is save a copy in your Google Drive, and then we'll work with that. So now I've got a copy, and now you can make changes to this, and you can save your changes. So if I say save, now it saves the notebook. All right, so a notebook is a series of cells, and in each cell we can have text describing what's going on, or we can put in short little Python scripts. So you can see this first cell, I've put quite a lot in it. This is the whole screen telling what we're going to do today. In the next cell, I've then put a bit of an introduction, so you can type into a cell, and when you've typed into the cell, then you can press Shift Enter to execute the cell. The cells can be Python code or Markdown text, so these first two have been Markdown text. To get help, you can use the question mark or the help menu. So up here is the help menu. So you can search for stuff on that. Or down here in a cell, you can type a question mark. Now, these ones were Markdown, this one's a Python script cell. So you can see they look slightly different. And when you, in a Python script one, you can start the lines with a hash, and that just lets you type in comments. So comments in the code cells start with a hash. So let's try, we've typed in a question mark, and if I press Shift Enter, that'll now execute the cell. So you can see we've got the wait happening around the play button there. And it's the very first one you do will be a bit slow because it's got to start using Python. So here's our help. It's turned up over here, IPython, Enhanced Interactive Python, and that's what Jupyter Notebooks are based on. And it tells you all about it. So you can do, you can type question mark and a word to get help on a particular word. And you can also do question mark word. So that'll do for now, I think, with that. But really the important thing there was you press Shift Enter to execute that cell, and something came up. So we can close that. Now, one thing I like to look at is all the keyboard shortcuts for things that I want to do. So there's lots of things that you can do here. These are all the keyboard shortcuts. I'm running on a Mac at the moment, so I'll be using the Command key, but if you're on Windows, use the Control key. So if you want to convert to a text cell, you do Control or Command M, and then press M again, and that'll let you use markup. If you do Control M and a Y, you'll convert to a code cell, which is your Python code. The most important ones I like to do is inserting a cell above and inserting a cell below. So that's Command M above and Command MB for below. Okay. So I don't need to make any changes there. You can also insert cells here, insert a code cell, and that will insert one below if you can't remember the keyboard shortcut. So let's just do that now. If I do Command MB, it inserts a cell below. And we can put anything in that, but we don't know anything yet, so let's move on to variables. So just let me know if I'm going too fast, and in the chat. All right, so variables are memory locations where we store data, and you can name them anything you like as long as you don't use a Python keyword. There aren't many Python keywords, so you should be pretty safe, but we'll go through them later. So variable names, they have to start with a letter, and but they can include numbers in the name. So we're going to call a variable A. And to store a number in the variable, we use the equals sign. So we want to store the 3 in the variable A. So we say A equals 3. The reason they're called variables is because you can put different sorts of data, different data in there. I can put a 3, I can put a 4, I can put 5, it's all varied data. So it's the same as in all programming languages. You have variables where you store data. And they're really just memory locations, but to make it easy to access that memory location, you give it a name that you're comfortable with. So if I press Shift Enter now, that will execute that cell, and now in my memory location called A, I've got the number 3. So to see what's in that, in Python, I can run the print command, and that'll tell me what's in memory location A. So Shift Enter, and I get a 3 is the output. So you can see this is the output from running this cell. So that's in normal Python. That's how you would do it if you had to see the value of A. and but here we're in interactive Python, so we can also just type the variable name, and that'll go, well, you're interacting with us and you've typed the variable name, obviously you want to see what's in the variable. So pressing Shift Enter on that, or I could have pressed the play button, it says the value in A is 3. In interactive Python, we can also type in expressions and it will do the calculation for us. So for example, I could type A plus 4, and if I run that, this time I'll run it by pressing the play button. It tells me that the answer is 7. So it's just told me the answer is 7, hasn't saved it anywhere. But if I want to save that, I can use my variable name equals and store the results of an expression in the variable. So in this next cell, I'm going to do that. I'm going to do an expression, A plus 15. I'm going to divide by 4, and I'm going to store the result of that in the variable B. But I then want to see what is in the variable B, so I just type B on a line by itself. And interactive Python will go through these lines one by one in sequence, and whatever's on the last line, if that's got some value, then it will display that for us. So it tells me B is 4.5. Now if I put A after the B and tried executing that with Shift Enter, it just tells me the value of A. So A was 3, 3 plus 15, 18 divided by 4 is 4.5. So it's only the last variable that will get displayed. If I put print statements on every line, then it would have given me all the, I would have seen the results of every line. Every print statement will run, but only the last one is displayed in interactive Python. Okay, oh, good to see I've got a few people watching and saying hi on the YouTube chat. Right, now we're going to jump straight into something a little bit more advanced, just for people who've seen Python before and are getting bored. But if you're brand new, don't worry about this. What I want to do is see what the list of all the Python keywords are. And I want to do this because I want to make sure I don't call any of my variables by a Python keyword. So I'm going to import these libraries that allow me to do that. One of them is going to give me the list of keywords, and another one's going to tell me what version of Python I'm currently running. So if I run this, it'll run all the lines in here. So there's 7 lines, 3 of them are comments, so they don't do anything. 2 of them are imports, so they'll just load those libraries, and then the 2 print commands will run one after the other. So the first print command said the Python keywords are, and it gives you this long list of Python keywords. And then it says there are 33 keywords in Python 3.6.9. So that's a list of 33 words there. So don't use any of those as variable names. Python 3.8, by the way, is 35 keywords. So they've added 2 more, async and await, to the list from Python 3.6. All right, so during today's session, we're going to try to cover 15 of these keywords. So almost half of Python we're going to cover tonight. So it's a really good beginner session. All right, I see someone called Forever is saying this is their first time and they're lost already. So let me know if you managed to get into Google Colab and you've got the notebook up with the stuff that I've got on the screen. And in the chat, if someone asks a question in the chat and I don't see the question, anyone else feel free to try to answer it as well. Okay, so one of the keywords is none. I thought, well, I may as well start with that one. None is a value you give to a variable if you don't want it to have a value. So if I say n equals none, hasn't got a value, I type what's in n, and it doesn't show anything because it's got nothing there. All right, covered off one keyword. Another keyword is pass, and that's a word that does nothing. So if you need something in your script to do nothing. By the way, this is still a bit more advanced stuff, so don't worry if you're your first timer. We'll get back onto the first timer stuff very soon. So if you run parse in your programming Python script, then it does nothing as well. So there's two easy things. None is no value. Parses do nothing. You sometimes need it just when you have to get the indentation right on your code blocks, but we can worry about that later. Okay, so Forever is saying in Colab he got the first line, but he's stuck on opening the second. Oh, okay. So to run the first line here, so this is the first line here. Well, actually this one here was the first line. So you've got that line and you want to create a new cell below it. You can go up to this insert menu and say insert code cell, and it'll give you a blank cell underneath. There's also keyboard shortcuts, but we'll just go with the menus for now because they're a bit easier to follow. And then in the cell you can type something. So this one's a code cell, so we can type in some Python code, and just like a simple mathematical expression is some Python code. So if I type 3 plus 4, and then I run that by clicking on the play, I should see 7 coming underneath. So you can just go down on each one of these and click play, and it will just run each cell. And these text cells, the markdown text cells, they don't have a play. And they don't have the rectangle around them. So every time you run on play, you should get an output. If there is any output, a equals 3 doesn't have an output. It does something. It doesn't display anything. So it just stores the value 3 into a. All right, good. Yes, if anyone else has got questions like that, please feel free to ask. Right, so we're naming variables. We've called it A and B. You can have longer names, and in the Python convention is to use underscores in your variable names. So here's a variable name called a long variable name. So I can use that and store in that the number 345, and then to display it I just type a long variable name after that. There we go, and it displays 345. All right, now there's a function here called type, which will tell us the types of these variables. So far we've been looking at numbers. 345 is a number. So let's see what Python thinks the type of it is. And so Python's calling it an int. So that's an integer. It's a whole number. So it's got no fractional part. So it can be negative. You can have -5 as an integer. 0 as an integer. In this case, I think it was 3. So that's an integer. And so that's a data type called int. And one of the great things about Python is that you don't have to say what data type you're going to use. You just got your variable and you just put any data you like into it, and that you can put an integer into there. You can put any of the other ones which we're going to come across later, and the same variable can be used with different data types. While other languages like Java, you have to define beforehand what variables, data types can go into a variable. All right, we'll look at the type. We can find the type of actually what something we've typed. That's called a literal. We've typed in 456, and what's the type of that? Once again, that is an integer because it's a whole number and it's got no fractional part. All right, remember we did calculate a b before to be 4.5. So Python's saying the type of b is a float, and the reason it's called a float is because it's a floating point number. Floating point means the decimal point can move, and it's the way Python represents the numbers it stores them in memory and allows it to store really big numbers and really small numbers in a fixed amount of memory. The way it does that is it stores it as a number with a decimal point, so 1.23456. So this is, I've typed this number in, and this is the way it's storing it. And then it's got e plus 19, so that's times 10 to the 19th. So the 19 is saying where the decimal point is, and this other part of the number is the mantissa, and that's just the value of the number without multiplying it by. So it will always just start with a 1 point or 2 point, but it'll this one here says the mantissa is saying where the point is, and that means it floats around. So similarly, we could have a very small number like this one, and that's by 10 to the minus 14. So you've had to move the decimal point 14 places to the left, and then you just type in 1.234. So if you hit there and then you go 14 places to the left, that's where it really is, but this is how it's stored, so it doesn't need to store all these zeros here. It just counts them by this exponent. All right, so we've done two data types. I've got another question here. What does the F mean before the string on the print command? Yes, we'll get into that. That means it's a format string, and this is it's a new thing in Python 3.6 and later, and it's a way of displaying different numbers, formatting the text so you can put variable values inside a string, but we'll get more into that later. Python seems to be mostly lowercase language from what I've seen. Is that why variables contain underscores between words? Yes, that's right. So it's Guido van Rossum is the guy who designed Python. He also put out some conventions on style guides on how to write Python code, and he said it'd be really good if your variable names are all lowercase and you use underscores between the words. Other things like classes, he says for those it's best to use no underscores and put capital letters at the beginning of each word. And that way, by having those two different conventions, you can tell by looking at something whether it's a variable name, variable or function name, it can be a function name as well, or whether it's a class name, in the class name has got those capitals in it and no underscores. Do you have to initialize variables before calling them? You do. So, and remember you're in interactive Python here, so you can check some of these things out. So I'll just create a new cell below. So I could have gone up here and said insert code cell. And let's just call a variable d, and it say d is not defined. So you can't do anything with a variable if it's got no data in it. So if I said d equals 5 and then d, then it can do something with it. It tells me it's got the value 5 in it. So, but I really encourage you to try these things out. Like, learning by doing is a fantastic way of learning, and I think the Python, interactive Python, is just such a good way of doing this. I'll often sit down in an interactive Python session and try out a few things while I'm writing code, and then go back and put it into code once I've worked out exactly how everything's going to behave. Right, so we've done integers, we've done floats. Now we want to store text, and text can be stored as strings of Unicode characters. And this is really one of the big differences between Python 3 and Python 2. Text in Python 3 is stored as Unicode characters, and Python 2 it was stored as bytes. I recommend everyone just steers clear of Python 2. It's pretty much end of life. There's just a couple of people still programming in Python 2 because they need that backward compatibility. But everything you do in the future can really be done in Python 3. So we're going to deal with Unicode characters. So to create a string, we just have to enclose the text in quotes. Now those quotes can be single quotes or they can be double quotes. They really act the same. The advantage is if you use a single quotes around your string, it means that inside the string you can have double quotes and it won't try to end the string. So if you know you're going to have double quotes inside the string, then you use single quotes outside your string. Similarly, if you've got single quotes inside the string, such as in S2 here, then you enclose your string in double quotes. So that's pretty easy. But sometimes your string might have single quotes and double quotes. So in that case, you can use what's called the triple single quotes or triple double quotes. And the advantage of these is that you can put in single quotes and double quotes, and you can even put in line feeds. So at the end, after embedded, there's a line feed that drops down to here and continues on the same line to say the rest of the line. And that can all be stored in S3. And similarly, S4 is using triple double quotes. So let's try printing these out and see what they look like. And let's have a look at what the type of S1 is. So you can execute these cells as well as I can. So when you print them out, it doesn't print the quotes. It just prints the string that's inside the quotes. So in this one, you can now see it's got double quotes are inside that string, just as we wanted, and the single quotes are inside this one. For S3, when we typed in the string here, we had a string in triple single quotes, and we had line feeds nicely aligned under the A. But when it prints out, we get all these spaces here, and that's because it actually counts all these spaces here straight after the new line. So if you don't want those spaces to show, then when you do a line feed, you have to continue on the text hard up against the indentation, hard up against the first character in the line. So there's our 4 strings. The type is coming str. So remember we've got int for int, float is the full word float for floating point numbers, and str for strings. Now sometimes you want to put special characters in, like there's a reason you have to use, you can't use the triple single quotes or the triple double quotes. So in that case you can put a \n for new line, \r for carriage return, quote for single quotes, double quote for a double quote, and double / if you actually want a \. So this is more advanced. It's really just showing it to you for people who are familiar with other programming languages where this is quite a common way of doing it. So if I now printed that, you see I'm using the print command and I put commas between each of the things that I want printed. So what I want to do is print the number 1, then I want to print special character 1, then I want to print the number 2, special character 2, 3, special character 3, 4, special character 4, 5, special character 5. So let's see what happens when I run that. Okay, so this is what I get. I get 1, so it's printed the 1 fine. Special character 1, which means a new line. So it's dropped down. I've got no 2. Where did the 2 go? And what's happened is it's printed the 2, then it's done the carriage return. And the carriage return is like the old typewriters. New line is the same as rolling the platen around, and carriage return is when the whole carriage, which is where you're typing onto, has to return back to the beginning on the next line. So to start a next line, you would, in the old typewriters, you'd go down a new line and then you'd move the carriage to the beginning of the line, and that's why you get new line carriage return. So what it's done, it's printed the 2, then it's done a carriage return back to the beginning of the line, and then it's printed the 3, which has overwritten the 2, and so we don't see the 2 at all. But we do see the single quote, so that's a string with just a single quote in it. We do see the double quote, and we do see the backslash. So this form of the print command with the commas, it by default will put a space between everything that you're printing, but it'll print them all on the same line, unless of course you've got Newline characters in there. Right, now what's something with Python strings that are different to other programming languages is that you can put these letters in front of the Python string, and that defines what sort of string it's going to be. So if we put a U, and there's only 4 letters that you can do, but you can actually have more than one of these letters in front, because sometimes you might want to have a Unicode string that's also a format string. So you could do UF, or you could do RU. You can't do UB because U means Unicode string, B means byte string, so it can only be one of the two. So Unicode is the default in Python 3, so you don't have to put a U there, but if you want to write some code that'll work in both Python 3 and Python 2, then you should put a U in front of every string. Similarly, with byte strings, if you're in Python 2, you don't need to put the B there, but in Python 3 you will. So if you're writing compatible code for both, then put a B in front of every string. Now raw strings, basically a raw string just says a backslash is a backslash, it's nothing else. So this makes it easy when you're having to create a string that's got backslashes in it, so that you don't want to have to keep escaping the backslashes, because it makes it really complicated. Every time you want 1 backslash, you have to type in 2 backslashes, and if you want 3 backslashes, you've got to type in 6 backslashes. And in cases where you're doing regular expressions, that actually becomes really, really difficult. But by having this ability to use a raw string, and then a backslash is just a backslash, then this makes it a lot easier. And finally, the format string allows you to include values and expressions. So if you start with an F in front of the string here, then you can put these curly braces in your string, and anything that's inside curly braces, it will evaluate and display the answer rather than display the curly braces. So let's have a look at what that looks like. I'll run that by clicking the play button here. So our Unicode string looks right. Our byte string, when Python 3 is showing a byte string, it actually shows the B and the quotes, because we really shouldn't be using byte strings unless you really need bytes for some low-level stuff. Our raw string, we can see all our backslashes. Nothing's been escaped there. And a format string, we can see that we've got 3 plus 4.5 equals 7.5. So the A has been replaced with 3, the B has been replaced with 4.5, and A plus B has been replaced by 7.5. Now there's a lot more we can do with these format strings, but I won't go into that now, but maybe later. All right. Operators. So we can create expressions using operators between variables or values, and so it's good to know what the different operators do. Some of them are very obvious. So plus, for example, is obviously addition. So why don't I just run this? And I've used format strings throughout. If you're having trouble understanding the format strings, then maybe try typing these things in just in cells by themselves, and rather than this complicated string arrangement that I've got. So for example, if I want to do A plus B, just type A plus B and play, and that gives me 32, which is the same as what we get in this first format string. 27 plus 5 returns 32, so that's addition. So the plus sign gives us addition, minus gives us subtraction, the asterisk or star gives us multiplication, And now to do integer division, we do // and to do modulo, which is remainder, we do %. So we can say that 27 divided by 5 is 5 remainder 2. And so the // gives us the quotient, and the % gives us the remainder. Okay, and star is power. So 27 to the 5th power is 27 times 27 times 27 times 27 times 27. And we'll just check that. And that gives us 14,348,907. All right, so these are what are called the integer operators, because we started with two integers. A and B are both integers. Now, what if A is a floating point number? What do we get? So you can see that if either of these values is a floating point number, we will get a floating point result. So in this case, we've got 27.0 plus 5, and that returns 32.0. So that's given us a floating point result there. And it could have been either. It could have been B was the floating point number. So you could have 27 plus 5.0, and that would also have given 32.0. But apart from that, the operators are still the same. Plus gives us addition, minus gives us subtraction, asterisk gives us multiplication, // gives us whole number division, so that returns 5. But now we can also use just a straight slash, or a single slash, and that will give us floating point division. % gives us modulo as before, but these two are both, even though they're whole numbers, they are stored as floating point numbers. And power returns a real number, a floating point number as well. So I'll just, another thing we could have done, if we had integer, but we use floating point division, so two integers but with floating point division, it would give us a floating point number as well. So regardless of the type of these, it being two integers, they will always return a floating point number. Now here's some really advanced stuff. You'll probably never come across this, so don't feel bad if you don't understand anything that's going on here. We're looking at the bitwise operators. And these are the pipe symbol, the ampersand, the circumflex, the double less than sign, the double greater than sign. So this is really just academic interest. You'll hardly ever use this stuff. So the pipe is called bitwise OR. So 10 or 3 gives us 11. And the way it calculates that is 1010 is how 10 is represented in binary, and 0011 is how you represent 3 in binary. And so if you do an OR on those two numbers, it looks, if you get a 1 and a 0, that gives you a 1 because it's that one or that one. So that gives us a 1 in the first column. We get a 0 in the second column because we've got both zeros in the second. There's 2 1s, one in each of the third column, so we get a 1 there. And in the last column, just the second number's got a 1. So the answer is 1011 in binary, and that translated back to decimal gives us 11. But one of the things that you can see by this is that we're using some fancy features of the format strings. Is we've got these colons here which say anything after a colon in the curly braces is how I want to format the result. So in this case, I want to format it justified to the right, that's what the greater than sign means, but 2 spaces wide. So you can see I've left a bit of extra space in there. by using that format string. In here, I've said I want it to be 4 characters wide. It'll be justified left because I haven't said anything about justification. But I've said I want it shown, the integer, I want it shown in binary format. So it's converted it to binary as 1010. Similarly for the number 3, I wanted that to be 4 characters wide in binary, but that would have given me 1, 1. And so I wanted it justified to the right, so I put in a greater than sign. And so that would have given me space, space, 1, 1. But I really wanted it to be 0 padded, so I put in 0 there. So don't try to remember all this stuff about format strings. But I recommend just use them whenever you can and read up on them in the Python documentation. Even at python.org, they've got some really good documentation on format strings and all the things that you can do with them. All right, so these other ones, ampersand, it's just bitwise and. Exclusive OR means if either of them are a 1, if you get a 1 and a 0, then the answer is 1. If you get a 0 and a 0, it's 0. If you get a 1 and a 1, it's also a 0. Shift left, it just shifts the bits to the left, so you can see 0, 0, 1, 1. The 2 1s get shifted to the left to become 1, 1, 0, 0. And similarly, 1, 1, 0, 1 shifted right by 2 gives me 0, 0, 1, 1. Don't worry about those if you don't understand them. But here's something that you should know, and that's how operators work on strings. So we've done integers and floating points. Now, what can we do with strings? So we can use the plus between 2 strings. We can even use multiply and an integer on strings. So if we run this one, we're going to get, let's see what we're going to get. We're going to get well, 3 holes in the ground. And that's right, because the first string we multiply 3 times, so we get it 3 times, and then we add it to the last bit, which is 3 holes in the ground. And if you're typing in adjacent strings with quote marks like this, then you don't even need the plus. If you have your strings stored in variable names, then yes, you definitely need the plus. But if you're just using adjacent strings that you've quoted literally like this, then you don't even need to put a plus between them, and that will just give you 1, 2, 3, 4 as the value of that string. And notice how it's put single quotes around it. That's because I haven't used print. So if I put all of that in print, it prints the value of the string, which is just the text without the quotes. And on the next line, I'll just do it without the print. And we see that it's showing me the value of that, and it's giving me a little bit more hint about what type of value it is. By putting the quotes there, I know it's a string value, and that's what interactive Python is doing. It's not, it knows you're not trying to write a program where you're producing this report. It's giving you as much information that it can about that value. All right, I've got a question, is should the bitwise operator be or be read? So that's really nothing to do with Python. The syntax coloring there is really Google Colab. So you're right, it probably should be read, but it's just confused their syntax colorer, so it's coming up in black. Right, so we've been playing around with these values, so let's have a look at some of the interesting side effects. Integers can have more significant digits than floats. So the floats are limited to about 17. I told you that they're trying to minimize the amount of memory that floats take up. But when it comes to integers, they go, oh, no, go for it, use it as much as you like. And so you can actually store a lot more digits in an integer. So 25 divided by 7, that's going to be a floating point result. But if I did this as an integer, but with lots of zeros there, it's going to work out the same values, just not have a decimal point in it. And we can see that we get about 17 unique values there stored in the floating point number, but the integer returns an integer with many more places. So you get many more significant digits by doing integer division. And that can be useful somehow, some places. Like I've seen some code where people are calculating the value of pi to 100 decimal places or 1,000 decimal places, and they've used integers to do that. Because if they tried to use floats, they'd be limited to 17 places. But by using very large integers, they can get all those significant digits. And then they just manually print in the decimal point at the spot they want it. Floats can't store decimal numbers exactly, so floats are really good for science work, but they're not great for accounting. So if you're writing some accounting software, you're better off to use cents, which are integers, or if you want to use dollars, there's a class called decimal, which you use for accounting, but we won't be getting into that today. So an example, if we added 1.1 to 2.2, the result we get is 3.30000 all the way up to 3 there. And it's because neither 1.1 or 2.2 are stored exactly, and when you add them together, it starts to, they have a digit that becomes significant for the display purposes, and it prints it. All right, so here's some challenges for yourself. I left some spare cells here to type things in. And so have a go with that. So I've got the question, normally if you log something in the console, do you not need the print statement? That's right. So if we're here on a interactive Python, so we don't need the print statement if we just want to see the value of something. So let's create a cell below. If I just type 12, it'll then display 12. That's an expression that it's worked out. Now, if I typed that into a Python program, it will do nothing. The Python program, it'll calculate 68, but it won't know what to do with the 68, so it'll just throw it away. It won't get displayed anywhere. But in interactive Python, it goes, well, you probably want to see the result, so it shows it to you. So it saves you having to type print all the time in interactive Python, so that can be great for these requirements. But yeah, if you're running programs, you don't want all these intermediate calculations being displayed. So in that case, it won't print them out. It gives you a lot more control over printing in a Python program, but it gives you a lot more information as you're going in IPython. All right, so how are we going for this? Add 1, 2, 3 to 4, 5, 6 and display the result. So that's pretty easy. You type in 123, put a plus sign between them. You don't need the space. I've put a space in there, but we don't need the space. And then we press the play, and that gives us the result. Find the quotient and remainder when dividing 66666 by 235. So I could do, I want to do the quotient, so it's integer division. And I also want to find the remainder. Now if I run that, it's only going to show me the last result. So I could put print statements around both of those, and that will show me both results. But the other thing you can do in Python is you can return two values on the same line, and you just put a comma between them and run that, and it returns the two values, 2836 and 206 are the two values. So this comes in useful later. You can you can actually assign two variables at the same time. So if I did x comma y equals that number, and run that, that'll store it in x and y, and we can't see the result. So let's print x equals x and print y equals y. So in that one line, I've assigned two values, two variables in just one line of code. So that's a nice little thing that you can do in Python. All right, 2 to the power 10. Power is the asterisk asterisk. Decimal quotient. So we just want single slash for division. All right, store in a variable the name of your favorite programming language as a string. So let's try s equals IPython. And then construct a new string. So let's call that s1, s2 equals, starts with programming in, and finishes with is fun. All right, and includes the name of the variable in the middle. All right, so I could use a format string here. So I put an F out the front, and I put S1 in there. And then let's have a look at what's in S2. And it's programming in IPython is fun. So that's how you can use format strings. Now I've got the solutions here. I've used format strings for these ones, and for the last one I didn't use format strings. I used string concatenation using the plus sign. So that's the other way you could do it. So I'll run those solutions as well, because I think I need C1 and C2 later on when I'm doing some other ones. Yeah, running Jupyter's quite fast. In fact, I'm finding Google Colab's a little bit slower today than normal. But yeah, if you're running Jupyter Notebooks on your own computer, it's quite fast. And if you're running Python directly, it's very fast. Well, not as fast as C or other languages, compiled languages, but it's can be very fast. Okay, another data type is bool, and that's a Boolean, so that really stores true or false. So true and false are keywords, so we're doing a few of the keywords here. We can look at what the type of true is and what the type of false is, and if I do that, they're both Booleans or bools. So you get a bool by using conditional operators, so they're really a testing operator to test something. So we want to test, does 3 equal 5 minus 2? And so you see here, rather than using the assignment operator, which is just a single equal sign, we're using the conditional equals operator, which is two equal signs. So we check, does 3 equal 5 minus 2? And the answer is true. Is 45 greater than 23? True. Is minus 10 less than minus 20? And the answer is false. Does C1 equal Python? And the answer is true, as we set that up here before. All right, so our challenge 3 is predict the outcome of all the following expressions. So I think we can just run this. So I think a lot of the speed is getting the Python up and running. Once it starts running, it gets through all these lines very quickly. Okay, C1 equals Python returns false because C1 is Python with a capital P. So therefore the double equals is case-sensitive comparison. Variables don't fall out of scope within a notebook. If you keep going in the same notebook, the same variable can be used, will keep its value all the way through. If you assign a variable a value in a cell, but you don't execute that cell, then that variable doesn't get the value. So let's create a couple of cells below. So in this cell, I'm going to say E equals 56. And then in this cell, I'm going to say, what's the value of E? But I haven't run the E equals 56. So I remembered it from a previous number that I had. So let's try another one I haven't used. J equals 56. And then, and then I ran it. So I did that wrongly. So what we're testing here, I type K equals 56. And then I, in another cell, say, what's the value of K? And it says K is not defined because I didn't execute that cell. So if I execute it now, and then I look for the value of K, then it will tell me it's now 56. And these numbers here are really telling me the order that I've executed them, so I can look back later and try to work out what's going on, why something hasn't come up. When you look while you're using Google Colab, there are some things that you can set. So in your notebook settings, omit code cell output when saving this notebook. So I've ticked that because I don't want all the answers to be shown here before you guys get a chance to run them yourself. So you can see what's come, everything that's coming in the answers in the code cell outputs is from what you've executed. But if you untick that, then you can save them from session to session. But I don't think the variables will keep their values from session to session, just the cell output will keep their values from session to session. Okay, C1 does not equal Python, so that's exclamation mark equals is does not equals. So that returns true, once again, because C1's got Python with a capital P in it. 253 is greater than or equal to 1518 divided by 6, and that's true, even though 1518 divided by 6 is a floating point number and 253 is an integer. They both have the same value, so they can still be compared with the equals. And similarly, that's a greater than or equals, and this is a less than or equals. It also returns true. Now here we're going to import a third-party library. It's not a third-party library, it's a standard library, math. So we're going to import a standard library. So math is not generally available to you unless you type an import command. Once you've typed that import command, you can start using some of the functions and constants that are in math. And we're going to use the value of the e exponent, the value for pi, and the value for tau. So we want to compare, is math.e less than math.pi? And the answer to that is true. So e is, which is your base for natural logarithms, is 2.71828, blah, blah, blah. And pi is 3.14159, etc. So that does return true. Now you can put these conditional operators in sequence and it checks both things. So is math.e less than math.pi times 2, and is math.pi times 2 less than math.tau? And let's see the answer to that. And so there's e, there's math.pi times 2, and there's math.tau. So we can see here that math.tau is actually equal to math.pi times 2. And so it's that part of it returns false because it's not less than, it's equal to. And so we get false there. Right, when we're comparing letters, A is less than C, because A is before C in the alphabet, so that returns true. And it's doing that by comparing on the Unicode value. But if we do compare lowercase a with uppercase C, we get false. And that's because the uppercase characters appear in Unicode before the lowercase characters. So the uppercase characters all have will all result in less than the lowercase. So if I say upper, all in uppercase, is less than lower, all in lowercase, that does return true. If I got a string catch and I want to compare it to carriage, returning less than on that, it compares the C's, they're equal, it compares the A's, they're equal, it gets to the T, you go up, the T is greater than the R, so therefore catch is going to be greater than carriage, so if you test for less than, we're going to get false. All right, similarly we can do with lists. We haven't dealt with lists yet, but this is a list of numbers in square brackets. We can do conditional on them as well. So it goes, is 5 greater than or equal to 6? And the answer is false, because like in strings, it compares element at a time. All right, another operator is the in operator. And it's one of the Python keywords. So we can see is the letters AT in catch, and that's true, because we can see the letters AT there, and they're in catch, and they're next to each other. So A and C in catch, that returns false because there's no AC with those two letters together in catch. TA also returns false because they're in the wrong order. All right, with lists, does 2, 6, is that in 5126? Now it's not in there because you can only use the word in with lists with one element at a time. So you could say, is 2 in 5126? It would say, yeah, that's true. And in that case, you wouldn't have the square brackets around it. You just have the number 2. And similarly, you can check 6 is 6 in 5126. Now you can see I've put in here not in, so that reverses the result. So 26 in there is actually false. So 26 not in there returns true, and that's what we get, returns true. There's a couple of other Python keywords here, which are or and. So true or false, that returns true. Yep. True and false returns false. And similarly, you could put you could have them around the other way. So you could have false or true returns true, false and true returns false. Now, if you have several of these one after the other, so true or false and false, it actually, there's an order of operators. So as you know, when you're multiplying numbers, that has precedence over addition of numbers. So for example, if I wanted to do 4 plus 5 times 6, that will give me 34. It won't give me 54 because it will work out the 5 times 6 first because of the order of operators, and then add the 4 on later. So similarly with or and comes before or in the order of operators. And so false and false is worked out, and so that comes out to be false, and then true or false will be true, and so we get true as the overall answer. Similarly, we can do false and false or true. Nothing special about that because that will give the same answer whether we did them just in sequence or the order of operators, because and comes before or. And you can see I've done that in this format string here. I've put 1 greater than 2, and that's just shown false when I've displayed that. All right, so what's the last one? C2 equals C1. C1 is C2. Okay, yes. So here's another Python keyword, is, and that's saying, do they refer to the same location in memory? And the answer to that is true. And so in this case, because I've said C2 equals C1, that is in fact saying let C2 point to the same part of memory as C1. There's a subtle difference between that and equals. If you're new to programming, don't worry about it at this stage. Okay, no questions on any of that. So we're doing quite well. All right, so let's look at a more complicated data type. And we'll look at the list data type, which we briefly looked at before. Now, a list you define with square brackets, and then you put in different values in there, and you separate each of the values with a comma. Now, the values you put in there, you can put in strings, you can put in integers, you can put in floating. In fact, you can put any data type you like into a list. And so let's store that list and print it out. So yeah, it's printed it out. Now, we want to refer to different elements of the list. We refer to them by their index. And their index starts at 0. So for the first element here, and goes up. So 0, 1, 2, 3, 4, 5, and 6. So if I say list square bracket 0 square brackets, that should give me 6. I was referring to the first element there. And then 1 gives me the next one, it's 5, and 6 should give me the last one, which is 0. Now, one really nice thing that Python provides us is, as well as doing indexes like this, we can count the index back from the end. So if we say -1, it says basically give me the value from the end counted back 1. So if I count back 1 from the end, I get 0. And so there it is, 0. Similarly, so let's just check that that's right. Yep, 0. And if I go -2, it should give me the string ONE, 1. Now that can be really useful. It means you don't have to keep calculating the length of the list and then say subtracting 2 if you want something close to the end. If you did want to calculate the length of the list, you can do it. There's a function, a built-in function called len, and so len of list will tell us that it's 7 characters long, 7 elements long. Now, in your square brackets, as well as putting individual indexes, you can put in a slice, and a slice can have a beginning and an end, and it will go from the first one that's counted up to, but not including the last. So it's everything between 2 and 5. And the way I like to think of that, I think the indexes are in between each number. So you've really got a 0 points here at the beginning of 6, 1 points there, 2 points there, 3 points there, 4 points there, 5 points there, and then 6 points there. So if I want everything from 2 to 5, it's really 2 is pointing here and 5 is pointing there. So I should get 4, 3, 2. So let's see what I get. 4, 3, 2. You can also slice from the beginning by not putting in, you could put a 0 in there, or you could leave it blank. That's the same, and that will give you 4 elements. So one of the advantages of the way they do this as well is that if I say 5 minus 2 gives me 3, I know I'm going to get 3 elements. In this case, I've got 4 minus 0, I know I'm going to get 4 elements. Slice from index 3 up to the end. This is probably more useful because often you don't know where the end is. without doing an extra calculation. So I could just say list 3 to the end, and that gives me 3210. Now with slices, you can even do some more complicated stuff, and that's you can put a starting value, a stopping value, and you can also put a stepping value. So we're going to go from 1 to the end, stepping in 2s. So there we go. So 1 is the value 5, then we go up in 2s, we get 3, and we get 1. And then you can start getting really complicated, and you can have minus stepping. Are pretty rare that you would ever want to do this. I don't think I've ever had, except maybe turning strings around. But this will start from the last one, go up to, but not including 1, and go backwards. So we get 0, 1, 2, 3, 4. But yeah, that's getting pretty complicated. I wouldn't ever do that, I don't think. All right, so let's see about, there's our list value. So that's list. Now we can assign an item at index 2 with a new value. So list 2, we want to change from 4.0 to the letters FOUR. So that's how we do that. All right, the comma counting tip, yeah. That also works with strings. So if you're looking at the index of characters in a string, you look at you count in between each letter. So you're going from 0 to 1 will be the first character, from 1 to 2 will be the second character. All right, we want to change list -1, so that's the last one, from 0 to blast off. So we can use negative indexes there as well, and that works. And here we go, here's strings, which we just mentioned. So how we do a slice, so we count 0 is just before the A, 1's between the A and the B, 2 is between the B and the C, 3 is between C and D. So if we go from 3, we're going to start there, and then we're going to go up to 4, 5, 6, 7, up to but not the H, so the 7 is between G and H, so we should have D, E, F, G is what we get. And there we get it, D, E, F, G. Right, so you see you can do stuff with strings like you can do with lists, and the challenge is what can you do in a list that you can't do with a string. So try those things that we've just done with this list and see what you can do with the string, what you can't do with a string. So it's pretty easy. We can do we can look at a character in a string. So we'll just use the string A, B, C, D, E, F, G, H, I, J. We can use negative indexes. That gives us the last character in the string. We can find the length of a string. Yep, it's 10 characters long. Let's see if we can slice a string. So we'll start from the second character, we'll go up to the 7th character, and we'll go up in 3s. And that gave us C and F. In fact, let's go up to the last character, C, F, I. All right. Now let's try to change the second character of the string to the character at index 2 to a capital. Right, so there's something we can't do with a string that we could do with a list, and that's we can't change a character within a string. And that's because strings are immutable. Which means we can't change any values in place. While lists are mutable, we can change the values in place. If we wanted to change, if we wanted the string to now have a capital C in it, we'd have to construct it from the old, but that's not changing it in place, that's storing it in a new memory location. So we can't do S2 equals, but we can do S equals, which will create a whole new memory location. And we want it to have the old value of the string going from 0 to 2, plus a capital C, plus the new value, the old value going from 3 up. And then let's have a look at S from that. So we've now got the string with a capital C in it, but we've had to construct a whole new string and then store that new string in S. We couldn't just change one character in place. All right, here's my solutions. I think I've covered all of those. Yes, we couldn't do the item assignment. We got a type error. So I didn't even try to do it in the solution there. I just said what would happen. Right, now because strings have a few of the characteristics of lists, we can easily create we can convert a string to a list and create a list from a string because it can iterate over that string. So let's have a look at what we get if we do that. So S is, I must have reassigned S here. I did, 6543210, and then when I created a list from that, it's taken each character as a separate element in the list. So any of these data types you can change between them. I should mention that. So I'll create a new cell here. So if I've got, so let's have a look what's in A and B and C. Oh, C is not defined. Okay. So, okay, they're integers and a string. All right, I'll set up some new values. So let's say A equals 45, and I want to show the float value of A. I can convert it to floating point by putting the data type name as a function around the value. So similarly, if I had it as a floating point to start with, and I wanted to convert it to an int, I can do that, even if it's, see what happens when I do that, it just truncates it. All right, and I can also convert it to a string. You see now it's got quotes around it. So if it was a string, let's try a float. I've converted it back to a float, so you can convert strings to floats. If I tried to convert that to an integer, I probably have problems. Yep, invalid literal. So I can convert a float to an int if it's got a decimal place. So if I wanted to, I could convert it to a float first and then to an integer, and I get my 45. Right, but what if I wanted to convert my list that I've created back to a string? If I do string over list from string, what do I get? I get a string that actually looks like that. It doesn't look like our original string, which was just 6543210. Now, something a bit more advanced for people, I can run the join function to do that. And what I'm saying is here, I've got a string, which is the empty string. It's got just 2 double quotes, so there's nothing in the string. But I want to use that to join all the elements of this list together. And if I do that, I'll get a string which is taken all the elements of the list, it's put an empty string between them, which is nothing, and created a full string from that. So that's what the join function does. And if you want to find out something about the join function, so let's try, we can use the inline help. Let's see if I got to select here, Command M below, and if I do help on string.join, that will give me return a string, which is a concatenation of the strings in the iterable, so the iterable being the list, and the separator by the elements, between the elements is S. And so our separator was an empty string, and so that's what we did to create that string back again from our list. Okay, let's get into some programming. We're going to, up to now, every time we've written a few steps, we've just been done them in sequence, and Python has just worked its way down, done one line at a time. But sometimes we want to make decisions in our program based on particular conditions. So we can use the if statement to do that. So the if will test a condition, and it will then decide which way to go based on the result of that condition that it's tested. And so it's going to choose a different code block to run. And this is called a code block here. And you'll see that that code block is indented from our main code. And this is something that distinguishes Python from just about every other programming language, is it uses indentation to designate where the code blocks are. The convention is 4 spaces. You might find if you're using Google Colab that it's designed for 2 spaces. You can fix that in Tools, Settings, Editor, indentation width in spaces. If you like the 2 spaces, then you can leave it at 2 spaces. It will still work. So I've set it to 4 spaces, which is the convention in Python. And so I'm saying I'm going to roll a die. I'm going to check to see if it's an even number. So I've divided by 2 and looked at the remainder. If that comes to 0, then I know it's even. And then I'm going to say you rolled an even number. And then the indentation stops. I go back to the original indentation. And so it knows that's the end of the code block. And I say the word else. So this else is linked to this if. I do a colon. So usually before a code block starts, you'll have a colon there. So you can see there's a colon on this line and a colon on this line. And we start straight into the next code block. And it says you rolled an odd number because it's obviously not equal to 0. So let's try running that with Shift Enter. You rolled a 6, which is an even number. So that sounds good. Let's try running it again. You rolled a 2, which is an even number. You rolled a 3, which is an odd number. So both sides are working. By the way, I'm using this standard library here, random, and in there's a rand range function, which rand range 6 gives you an int between 0 and 5 inclusive, and I want to convert that to 1 to 6 inclusive, so yeah, I've just added 1 to it. Alright, so say I've got 2 dice, and I want to get the 2 rolls. I'm going to store those rolls in a list. So I've just created the list, and by square brackets on the outside, comma in separating the elements, and then I'm going to evaluate both of those. Now I've got 3 different things that could happen. They could be, the first roll could be less than the second roll, the first roll could be greater than the second roll, or they could be both equal. So I'm testing for equality first, then I'm testing for less than, and I use if. So that's basically saying, if this is true, do this one, else, if this is true, do that one, and then else, which is all other cases, do this code block. Now I could have several lines of code in here, and as long as they were all indented the same way, same amount, they would all run, and it wouldn't assume the end of a code block. I can even start new code blocks inside them if I had another nested if statement, and that would require even further indentation. All right, you rolled a 3 and a 6. The first roll is less than the second roll. So it looks like that's working. Okay, so that was the if. Now, another useful thing in programming is loops. Okay, what does the end equals do in the first print statement? Yeah, so print is a function, and this tells you what you want to print, but you can also pass values into functions using named arguments. So print takes an argument named end, and it's got a default value. The default value is a new line character. But we don't want to do a new line because we want this print statement to follow on the same line as the first print statement. So what we do is we say print this, but I want the end to end with just a space. I don't want it to end with a new line because I want this one to be on the same line. So let's say, for example, I wanted that to be a couple of exclamation marks. If I ran that, you can see it says you rolled 1,5, full stop, space, then 2 exclamation marks. First roll is less than the second roll. Now if I change that to 2 exclamation marks and a new line character, it will say you rolled 2,6, exclamation mark, and now the next line gets printed. The next print statement prints on the next line. First roll is less than the second roll. So the 2 most common named arguments you'd use in a print statement are the end, they're saying that's what I want to be at the end. And the other one is, you remember before we were printing several values and they all had commas between them. The separator between those values is by default a space, but you might want it to print something else as instead of the space. So say, for example, I'll just create a new cell, Command M, B. So I want to print 1, 2, 3, 4, and I want the separator between each of those to be a $sign. And so it prints $1, $2, $3, $4. Okay, and if you want to see let's try the IPython help on print. So over here we've got the docstring, we've got all the values, there'll be several values, then you've got separator, you've got end, so there's got a file argument which defaults to the standard out, and you've got flush, and so the explains what this does. So flush you probably use when you're writing to files. Okay, so the way a for loop works, it's quite simple. It just iterates over something. So you say for something for a variable name in, and then something it can iterate over. So this variable name here, it'll go through the loop by the number of times of elements you've got in your iterable value, and each time it goes through the loop, your variable will have the next value that exists in there. So the first time through it'll have the value 3, then the second time 2, and then the third time 1. So that we get 3, 2, 1. It's printed 3 times, each time a different value. So for loops are quite useful. Another type of loop is the while loop. You can say while some sort of condition is true, it will do something, and it'll then go back and test the condition again until that condition is false. And when the condition's false, it'll jump out of the loop and finish. So you can see here with the way indentation works, we've indented, there's a colon at the end here, so say the code's going, look forward to some code block. It'll be all indented from now on. So that is all indented until the code block ends. And then we've got an if statement, and we've indented further because we've got more colons we're starting new code blocks. You've got to be very careful doing while loops to make sure you don't end up with an infinite loop. So there's got to be something in this code block that's going to change our condition. And here we're going to keep adding 1 to the counter until it gets above 10 or equal to 10. So let's run this code. It's the first time through, counter is 0, you roll 2, 2, they are both equal. You roll 5, 1, first roll is greater than the second roll, and so on. So that's the loop. Right, so challenge 5, have a go at this one. Write a program which prints every number from 0 to 20 as digits and its name in words, as well as whether it is even or odd. So you can see I've created a list here. I've put it in a variable I've called numbers. And if I use the index in the numbers, so you see what's happened here. I didn't execute this one, so even though I typed it all in, I need to execute it so that numbers has actually got a value in it. And then when I say numbers 6, it gives me the word SIX. So if I put in numbers and the numerals 1, 4, it gives me the word 14. So it's, I've managed to get a converter here that translates digits into words. So think how you might want to write this program. Have you got any questions in the chat while you're thinking about that? I can answer any questions. I've got a solution here, but think of different ways of doing it. You don't have to follow the solution. One extra function that might be of use is if you want to find out what the index is of a particular value in the list. You could say, give me the index of 5. F-I-V-E. And, sorry. I get my languages mixed up sometimes. Oh, I know what I'm doing. I'm not subscripting it, I'm calling it as a function. That's right. So if I put in a value into index, it'll tell me what the index is of that value. So can anyone think of a way of doing this using a for loop rather than a while loop? Howard's asked, is there a type of loop that does not perform the test on the first iteration? And the answer is no. Like I've seen repeat until in other languages, but in Python it's always the while is one of our keywords, but it's that loop will always do the test at the beginning. I've also seen do while in other languages. So if I wanted to go through all the numbers. I can do that, and then I can find out what my index is, equals and then I can print the index as digits, and then the number in words. Okay, and the only thing I haven't got is whether it's even or odd. So you can try using the code down here to print whether it's even or odd. And for the more advanced people, you can try doing this. You can try doing it in one line. So there's a way of using the if statement. Don't worry about this if you're a beginner. We want to print odd if index %2, else even. There we go. So you can work out, if anyone can work out how that works. Yep, range is a good way of doing it as well. I was going to show range. And if you use range, you don't need to know the index here. We can just use the numbers. So let's try range. That's a very good solution for index in range. So range is a function that will produce an iterable list of values, and we want to do from 0 to 20. So that's 21 different numbers, and by default, so once again we can provide a start value, a stop value, and a step value. If we only provide one value, it'll be the stop value. It'll assume 0 for the start value, it'll assume 1 for the step value, and we'll assume 21 as the stop value. So then we can do this in 2 lines. Because we don't need that extra line. That's how you do that. So, and we could use, let's use the format strings. So in our format string, we're going to show the index, and we want that to be a right justified 2 characters long and a decimal number. Then we're going to show, don't need the comma, this, and we want this to be left justified, but let's make it say 15 characters wide. And then the last value, so I might just change this to use single quotes. And we want that, we don't even need to do formatting on that one. And then double quotes to close it. And I've left a comma in there, I'll get rid of that. And so everything's nicely lined up using format strings. Okay, and let's have a look at another way of doing it. So I've used the while loop, I've used length to work out the length of the numbers, and I made sure that I added 1 to I each time it goes through the loop. So I could have said here I equals I plus 1, or this notation says change the value of I by adding 1 to it. and I check for whether it's even or odd, and then I print out the I, even or odd, and the name of the number. So with these inline if statements, what it does, you provide two values, and the first value, so I'm saying I want it to be odd if index %2, so index %2, that'll be a value to true if it's not 0 and false if it's 0. So if that comes to 1, then this will be true, it'll give me odd. Else, so otherwise, give me the word even. If this is false, give me even. If it's true, give me odd. So these are the keywords we've covered today. See if you can remember what they all do. We'll print that. Keywords covered 15. So we covered 15 of the 33 keywords. Any questions? Next week will be a machine learning. It'll be run by Arun. And so he does an excellent job of showing us all about pandas and NumPy and scikit and all the machine learning tools, and gives us some excellent examples. So I'd recommend coming along to that. It's not so much programming, but if you've understood what we've done today, then it'll be a good start for next week. And he's also very helpful if you ask questions. So if there's no further questions, I'm going to quit the video. I'll keep listening. Oh, the chat will stop actually, so the YouTube chat will stop. So I'll leave it going for just a couple of minutes. And I hope you all enjoyed it. Thank you very much for your kind comments. You can click on like if you liked it. And also in the comments you can, if there's anything in Python that you particularly would like to learn about, or just mention it in the comments, and we can see if we can put together a session on that. So I'd recommend also installing Python onto your computer so you can run it even when you haven't got internet access, and try using that. Okay, thank you very much.